Hello everyone again and welcome to my channel. On my previous video we looked at this trapping reactive intermediate by cycloaddition reaction, and now we're going to focus on the second way by which we can actually perform this type of reaction. Now the second way is by an intermediate called the Oxyallyl cation, which is actually generated from an alpha-alpha dibromoketone with a zinc metal. Now let's look at the first step in this particular process. First step is the introduction of a zinc metal with 2 electrons in its valence electrode or electron shell, which actually donates electrons to the oxygen region where we have a symmetric molecule, which is the alpha-alpha dibromoketone. So the introduction of these 2 electrons to this oxygen causes the double bond over here to donate electrons over here, then pushes this bromine here, and this bromine then forms a bromide, and the bromide then interacts with zinc over here. Now what we get as a result is the formation of our minor intermediate, I must say, where our bromine interacts with zinc and zinc has interaction, I'll say bonding with the oxygen, where on one side we have a double bond over here, however on the other side we have our bromine over here. Now what we notice is that the initial bromine couldn't leave because the bromine was next to the electron withdrawing carboxyl group. So as a result of what we have over here, what we get is a leaving group, which actually is caused by the non-symmetry that we have over here. So the leaving group leaves, and what we get is a bromide ion being generated, and this leads to the formation of a carbocation at this region. What we get is this. And this particular intermediate is called the zinc alunate formation, and this is the alunate over here, and while on the other side we have the zinc interacting with the alunate. Now what we notice here is we have 3 systems over here, and this 3 system is really crucial because we will actually stabilize this particular region by introducing a diene, and our diene will be important in here because our diene, which is the LUMO, will actually stabilize the LUMO state over in this region, since this region is highly unstable due to the carbocation generated at this region. So what do we have in here? Now drawing the molecular orbital system, what we have is looking at the pi or wavelength of 2, or which is the possibility here. What we get is the shaded, unshaded with our nodal plane, and while on the other side we have shaded with non-shaded, and we have a nodal plane over here. Reason is because we are looking at the LUMO, where the LUMO or the overall system over here has only 2 electrons, 2 pi electrons, which is in the HOMO. Then the next step is one plane, nodal plane, with no electrons in the LUMO. Now on the other side in here we have our HOMO, which is just the pi 2 or the wave number of 2, and what we get is a rotation of our bond, which is by a 4+3 cycloaddition reaction over here. So what we get is this comes over here, that comes here, that then comes here, and what we get is the formation of 2 sigma bonds with a loss of a pi bond over there. Now this leads to the formation of a minor intermediate, and this minor intermediate has a positive charge on this carbon, which generates a carbon cation and a double bond over at this region, while we still notice that with zinc is still bonded with the bromine. Now what happens next is that for we to be able to stabilize this carbon cation over in this region, this bond will have to cleave between the the oxygen and the zinc, and what we get is the reformation of our double bond, and this will be stabilized by the lost bromide ion, which is the negative charged over here. This negative charged then interacts with zinc, and then this bond cleaves over there, and what we have is the formation of our product, which is actually trapping this particular intermediate over in this particular region. So our product is this. Just wanted to confirm, sorry for my drawing is not as fantastic as I want it to be, but that's about it for this particular second step over here. Take note that we needed a 4+3 cycloaddition reaction over here to go through this particular step, and this will be pushed further to generate our product. And this is a good way to, or the second way, to actually stabilize our intermediate. Thanks for watching, really appreciate it. See you all on my next video. Hit the like, share and subscribe to Ebony Radio, and remain smart. Bye.